Section 9.1.50. By how many times does the sample size have to be increased to decrease the margin of error by a factor of 1/10? Okay, so factor meaning that we're multiplying it by 1/10. So let's take a look at the sample size formula. We know that the sample size formula, n is equal to the point estimate times 1 minus the point estimate over times the critical value over the margin of error squared. Okay, so what we want to be able to do is what we first need to take a look at two errors. Okay, so that means that if we have an error that's going to increase and then it's going to decrease by our margin of error, that means you're going to have two types of errors. Okay, so we're going to let E1 be the initial error, and we're going to let E2 be the final margin of error. Okay, so when the margin of error decreases by a factor of 1/10, okay, what that means is that when it decreases, and let's go ahead and write that. So when the margin of error decreases by a factor of 1/10. Well, what that tells us is that if we have the final margin of error, then that's going to equal 1/10 times the initial error. And so now what we're going to do is we want to be able to solve for the following ratio. We want to solve for the ratio of E1 over E2. Okay, so we're going to use this formula here. So we know that we have E2, which is equal to 1/10 of E1. So the first thing we're going to do is we're going to multiply both sides by 10. So we have 10 times the final error, which is equal to, this becomes a 1, so that's 1 times E error 1, which is the initial. And then if we want to solve for that ratio, we're going to divide both sides by error 2. So therefore, we get the ratio of error 1 divided by error 2, which is going to equal 10. Okay, so now that we've done that, what we want to be able to do is we want to determine the ratio of N2 and N1. So what we want to do is we want to find the ratio of N2 to N1 where N1 is the initial sample size and N2 is the final sample size. Okay, so let's use this ratio now. So we know that the initial N1, okay, is going to equal the point estimate times 1 minus the point estimate times the critical value divided by the initial error. And then N2 is going to equal the formula of the point estimate times 1 minus the point estimate times the critical value, this should be squared, times the critical value, and that's going to be divided by the final error squared. Okay, so what we're going to do is we're going to now use this as a ratio. So the ratio now is going to be the following. So that means that we have N2 divided by N1, which means that this N2, this point estimate times 1 minus the point estimate times Z alpha divided by 2 over the error of 2 squared is going to equal the point estimate times 1 minus the point estimate times, again, the critical value divided by the error or the initial error squared. Okay, so what happens here? Well, what we want to do is we're going to simplify. So that means that we can simplify that and that because that becomes 1. So then what's left is now we have N2 over N1, which is what we want to solve. And so now what we have is we have in the numerator we have Z, or the critical value, divided by error 2, and that's squared. And then we're multiplying this by 1 over Z alpha divided by 2 over error 1 squared. Okay, so if we want to rewrite this currently right now is 1 over that. So if we want to rewrite that in the numerator, then we need to take the reciprocal of what's inside the bracket there. So therefore, we now have Z alpha divided by 2 over E2, and that's squared, times, now we're going to take the reciprocal, so we have E1 in the numerator, and in the denominator we have Z alpha divided by 2, which is a critical value. Okay, so what happens here is that when we multiply these together, okay, this is what we get. We get, in the bracket, we have Z alpha divided by 2 times the error 1 over error 2 times Z alpha divided by 2, and that entire thing is being squared. Now the critical value is going to become 1. So now what's left is, still have N2 over 1 is the value of error 2 divided by, not error 2, that's error 1 divided by error 2 squared. Well, what do we know that equals? Well, if we take a look here, we know that error 1 divided by error 2 is 10. So we can plug that in for 10. And so therefore, we can say that that's going to equal 10 squared. So N2 divided by N1 is going to equal 100. So going back to the question, it says, by how many times does the sample size have to be increased to decrease the margin of error by a factor of 1/10? Well, then we can say that the sample size must be increased by a factor of 100 to decrease the margin of error by a factor of 1 over 10.